Welcome back, students. So in this video lecture, we are going to learn about the tests of divisibility. So there are a lot of tests that you can use to directly find that whether a number is divisible by a certain digit or not. So let's start with the divisibility by 10. So how can you check the divisibility by 10? So there is a divisibility test for this divisibility by 10. If the ones digit of a number will be 0, then the number is a multiple of 10. If the ones digit is not 0, then that number is not a multiple of 10. So for checking the divisibility by 10, for checking the divisibility of a number by 10, you just need to focus on its unit digit. If that unit digit is 0, then that number will be divisible by 10. And if that number is some other digit other than 0, then it will not be divisible by 10. We can take this number CBA, this CBA. This can be easily written as 1000 into D plus 100 into C plus 10 into B plus A. So for this number to be divisible by 10, the value of A has to be 0. If A is other than 0, any other digit like 1, 2, 3 or anything other than 0, then this whole number will not be divisible by 10. Now we have the divisibility by 5. So for the divisibility test for a number to be divisible by 5 is that the ones digit of that number should be either 0 or 5. If the ones digit of that number is either 0 or it is either 5, then that number is divisible by 5. You can take this number again. Now it can be written in the generalized form like this, plus 100C plus 10D plus A. Now for this whole number to be divisible by 5, you just need to focus on the ones digit, that is A. A has to be either 0 or 5. If A is 0 or 5, then this whole number is divisible by 5. But if A is some other digit other than the 0 or 5, then this whole number will not be divisible by 5. So these are the two divisibility checks. First one was for 10 and the other one was for divisibility by 5. You need to remember these rules for both of these. Now we are given a question to try that if the division n divided by 5 leaves a remainder of 3, what might be the ones digit of n? So we know that when n divided by 5, then this will give a remainder of 0 when our n will have a unit digit as 0 or 5. But now since this is the case when r equals to 0, then n equals to either 0 or 5. You can say or 5. But what if r is now 3? R is given to be 3. Then what will be our n's unit place? It will be either 0 plus 3, that is 3, or 5 plus 3, that is 8. So what might be the ones digit of n? They can either be 3. The answer is either 3 or 8. This is how you check this out. Because you knew that the remainder will be 0 when n will have the digits at the unit place as 0 or either 5. But if the remainder is given to be 3, then you will add 3 to the 0 to 0 as well as to 5 and you get 0 and 8. Next we have n divided by 5. This leaves a remainder of 1. Now what might be the ones digit of n? Similarly, you will add this 1 to 0, you will get 1 and to 5 you will get 6. So these numbers, I'm not telling you the explanation again. It's just like the previous one. Now the remainder is 1 instead of 3. So you're adding 1 to 0 and 1 to 5. So the number will be either 1 or it will be either 6. This third part is just same. Again with the same, just like the previous two examples. Now you have the remainder as 4. You can do it yourself just like the previous two examples. Now we have the divisibility test for divisibility of a number by the digit 2. So how and when is a number said to be divisible by 2? If the number has the unit digit as either 0, 2, 4, 6 or 8. That is, if the number is even, we can say. If that number is even or has the unit digit as 0, 2, 4, 6 or 8, then the number is divisible by 2. Take the number again, dot till CBA. This is in generalized form is written as this, 100C plus 10D plus A. Now for this whole number to be divisible by 2, this A should be an even number, that is either 0, 2, 4, 6 or 8. So we have this: if the division n divided by 2 leaves a remainder of 1, what might be the ones digit of n? Just like when we had to test here, instead of 2 we had 5. Just the similar way you have to solve this question. Now we know that when n is divided by 2, we have a remainder 0 when n will have the unit digit as 0, 2, 4, 6 or 8. But now we have a remainder as 1. That is, you are adding 1 to this remainder. That is, you will be adding 1 to all these digits as well. Therefore, the answer will be 0 plus 1, that is 1, 3, 5, 7 and 9. Therefore, the ones digit of n can be either 1, 3, 5, 7 or 9. Now we have that the division n divided by 2 leaves no remainder. That is 0 remainder. What might be the ones digit of n? I have already told you, it will be an even number. 2, 4, 6, 8, 0. Now we have that, suppose that the division, we have both of the division, n divided by 5 as well and n divided by 2 as well. So when n is divided by 5, it leaves a remainder 4. And when n is divided by 2, it leaves a remainder 1. What must be the ones digit of n? When we are dividing the same number by 5, we are getting the remainder 4. And when we are dividing the same number by 2, we are getting a remainder as 1. What is the ones digit of that number n? So we know that in the case of n divided by 5, that leaves a remainder of 4. The possibilities are 0 plus 4, that is 4, and 5 plus 4, that is 9. So n can either have the digit at one's place as 4 or 9. And now for the case of 2, when n is divided by 2, it leaves a remainder of 1. But you know that when the ones digit will be 4, then the remainder will be 0, because 4 is actually an even number. Therefore, 4 cannot be the answer for that. Therefore, the answer is 9. So, what is the ones digit of n? It is 9. Because even if we divide n divided by 2, it leaves a remainder as 1. And similarly, n divided by 5, it leaves a remainder 4. 4 cannot be the answer, because when 4 is divided by 2, the remainder is 0. 4 gets fully divided by 2. Now we have the part 2 for test of divisibility. So what are the more tests for divisibility? Now we will be checking the divisibility of a number by 9 and 3. So these are both the same rules, like if a number n is to be divisible by 9, when does this happen? When the sum of its digits is divisible by 9. And if that is not so, then it is not divisible by 9. Similarly, the divisibility test for 3 is that if the number is divisible by 3, this is only in the case when the sum of its digits will be divisible by 3. Otherwise, it is not divisible by 3. So let's see it. See, if we have this number CBA, in the general form it is written as 100C plus 10B plus A. We can write it as 99C plus 9B plus A plus B plus C, which can again be written as, taking 9 common, we get 11C plus B plus A plus B plus C. So you know that this number will always be divisible by 9. This number is always divisible by 9. But what if you want this whole number to be divisible by 9? Your A plus B plus C should be divisible by 9. Hence, divisibility by 9 or even 3 is possible if A plus B plus C, that is the sum of the 3 digits, sum of all the digits of that number is divisible by 9. And similarly for the case of 3, your sum for all the digits of that number should be either divisible by 9 for the divisibility by 9 and divisible by 3 for the divisibility of 3. Now you're given example number 4 and you have to check the divisibility of this big number by 9. Now, that is, you are indirectly asked that whether this number is divisible by 9 or not. So you are not going to divide this whole number by 9, but you can use the divisibility check by 9. That is, if the sum of its digits is divisible by 9, then this whole number will be divisible by 9. So you'll be adding 2, 1, 4, 3, 2, 1, 4, 3 and then 6, 5, 8, 7. When you add all the digits, you will get 2, 1, 3, 3, 3, 6, 10 and then 10 and 14, 10 and 14 and 5 and 7. That is 7, 8, 9, 10, 11, 16 and 36. So the answer is coming to be 36. The sum, that is the sum of all these digits of this number, is 36. And you know that 36 is divisible by 9. You get the answer 4. You get the remainder as 4. That is 36 is divisible by 9. Since the sum of the all digits of this number is divisible by 9, therefore this number, you can directly say that this number is divisible by 9. Yes. You can say yes. Now we have this number and we need to check again the divisibility of this number by 9. This example number 5, do it yourself. You just need to add all these digits, and if you get the sum, if that sum is divisible by 9, this number will be divisible by 9. Again, we need to check the divisibility of all these numbers by 9. I'll do this first part for you. Do the other parts for more practice. So we have 1, 0, 8. So we need to add these numbers. Their sum is coming to be 9, which is divisible by 9. Since their sum of all the digits of this number is divisible by 9, therefore this number is divisible by 9. Do all the other parts. Now we're given in example number 6 that if the 3-digit number 24x is divisible by 9, what is the value of x? So you already know that this number will be divisible by 9 when the sum of its digits will be divisible by 9. That is 2 plus 4 plus x has to be divisible by 9. That is, it has to be some 9k, I must say. Therefore, we are getting 6 plus x has to be divisible by 9. That is, it is something 9k. You can add 9k minus 6. Or you can directly say it is 3 when k is 1. So, your x has to be 3. Because you will not be taking any number other than this. You have to take it as 9. Therefore, on solving this equation, you are getting x equals to 3. So, what is the value of x? It is 3. Because when you write it here 3, you get the number 243. And when you add all these numbers, because you cannot take, has to be a 1-digit number. You cannot take x, it has to be a 1-digit number. You cannot take it as a 2-digit number. Therefore, it has to be 3. Now, when you add all these numbers, you are getting 4, 5, 6, 7, 8, 9. That is divisible by 9. Therefore, this number is going to be divisible by 9. Now, you have some questions to think, discuss and write. First is, you have seen a number 450 is divisible by 10. Yes, it is also divisible by 2 and 5, which are the factors of 10. Similarly, a number this 135 is divisible by 9. We have checked it. It is also divisible by 3, which is a factor of 9. So, does this imply that if a number is divisible by any number m, then it will also be divisible by each of the factors of m? Let's just find out. See, I am taking a number that is divisible n. I'll take a number n that is divisible by a number m. Right? N is divisible by m and m is further divisible. I am writing m is further divisible by k. Therefore, n can be written as some m into x and m can be written as some k into y. That is, this n can again be written as putting this value ky x, that is k into yx. You can say that n is divisible by k, which is the factor of m, which is one of the factors of m. So yes, the answer for this question is yes. If a number is divisible by any number, say m, then that number will also be divisible by each of the factors of m. This is we saw like how this is true. I took some number n which was divisible by m was further divisible by k, that is k is one of the factors of m. And further I saw that n will be divisible by k as well. That is, it will be divisible by the factor of n as well. Next, we have the second part, that write a 3-digit number ABC as 100A plus 10B plus C. And do this, this can be written as 99A plus 11B plus A minus B plus C, which can further be written as taking 11 common, 11 into 9A plus B plus A minus B plus C. Now we are asked that if the number ABC is divisible by 11. So we are given that this whole number, the 3-digit number that we took ABC is divisible by 11. Then what can you say about A minus B plus C? So, if this whole digit is divisible by 11, you know that this is going to be divisible by 11 always. Does not depend on the values of A and B. But for this whole number to be divisible by 11, what can you say about this number a minus b plus c? This has to be divisible by 11, because only then you can take 11 common from all these values and this whole number will be divisible by 11. So what can you say by this? What can you say about this? A minus b plus c, this has to be divisible by 11. Similar question. Now we have this 4-digit number ABCD. This can be written as, like this in the general form, which can further be written as this, which can further be written like this. Now we are asked that if this number, the 4-digit number that we took, that is ABCD, if this number is divisible by 11, that what can we say about this value? What can we say about B plus D minus A plus C? So this part is going to be divisible by 11 any time, like always this is going to be divisible by 11 no matter what the values of A, B and C are. But for this whole value to be divisible by 11, this also has to be divisible by 11. Therefore, what can you say about this value B plus D minus A plus C? This has to be divisible by 11 also. This also has to be divisible by 11. Just like the previous one. So from both of these parts, the third part says that from both of these 1 and 2 part above, what can you say? Can you say that a number which is divisible by 11, if the difference between the sum of its digits at odd places and that of the digits at even places is divisible by 11? So is this always true? Yes, you can see that when we had this number A, B, C, D, we were saying that this part has to be, for this ABCD to be divisible by 11, we were saying that this part has to be divisible by 11. And this is nothing but the sum of B and D, that is the digits at the evens places, subtract like minus A plus C, that is the sum of the digits at the odd places. So, if the difference between the sum of digits at odd places and that of the digits at even places is divisible by 11, yes, from this part number 2, we can say that yes, this is true. I'll also tell you by taking an example. Let's just take this example, 2728. We know that this number 2728 is divisible by 11. But what if we take the sum of the digits at its odd places? That is, and the difference between the sum of the digit at odd places and that of the digit at even places. So 7 and 8 is 15. 7, you are going to do 7 plus 8 and you are going to subtract 2 plus 2 from it. So 7 plus 8 is 15 and you are going to subtract 2 plus 2, that is 4 from it, and that is 11. So yes, when this number 2728 was divisible by 11, we got this difference also divisible by 11 or vice versa. So you can say yes, this is true. I have taught you this method by taking an example also. That is 2728. Now we need to check the divisibility of this whole number by 3. In example number 7, we know that for checking the divisibility by 3, again we need to do the sum of all the digits. If that sum is divisible by 3, that number will also be divisible by 3. So what is its sum? 2, 1, 4, 6, 5, 8 and 7. Add this 2, 3, 6 and 4, 10, 11, 12, 13, 13 and 7, we get 20, then 28 and 5, 33. So is 33 divisible by 3? Yes. Now since 33 is divisible by 3 and this 33 was the sum of all the digits. So since we can say that the sum of all the digits of this number is divisible by 3, therefore this number is going to be divisible by 3. This is for the divisibility check by 3. Now we have some other number and we need to check the divisibility of that number by 3. Again, do this question yourself by taking the hint from the previous example. You are going to add all these digits and check whether the sum that you're getting is divisible by 3 or not. If the sum is divisible by 3, this number will be divisible by 3, and if it is not, the sum is not divisible by 3, this number is not divisible by 3. Again, you have some numbers and you need to check that whether these following numbers are divisible by 3 or not. I'll do the second part for you. Do the other parts yourself for more and more practice so that your concepts are more clear. 6 plus 1 plus 6, we need to check the sum. Now 6 plus 6 is 12 plus 1 is 13, but 13 is not divisible by 3. This is not divisible by 3. We don't get a whole number. Therefore, we can say that since the sum of the digits of this number is not divisible by 3, therefore this whole number we can say is also not divisible by 3. So this was all about the tests for divisibility. We saw many tests like 10, for 5, for 3, for 9, for 2, and so on. And then we use those divisibility tests in some examples also. Of all the parts that I have left for you, you need to practice those and get your concepts more clear. I'll meet you all in the next video. We will do the quick revision of all the concepts. Thank you.